All right, let's jump right in. We are about to go on a high-speed tour, starting from where you're sitting right now and going all the way back to the very beginning of time itself. This is a 14 billion year history, and you know what its subject is? It's you. Let's do this.
Okay, so it all starts with a really simple, tangible idea, just to get us grounded. Forget the cosmos for just a second. I want you to look out your window. It doesn't matter where you are. A city, a field, the coast, your immediate physical world stretches out to the horizon. And you know what? That horizon, it's only about 3 miles away. 5 kilometers. That's our measuring stick. It's the scale our biology, our entire being, evolved to understand. It's walkable. It's human. This is our baseline. Now get ready, because we are about to zoom out fast. Okay, let's make our first big leap. We're going from that cozy 5-kilometer horizon to the full diameter of the Earth, 13,000 kilometers. Just like that, in one single step, our entire personal world becomes nothing more than a tiny patch on this vast blue marble. And we're really just getting started. The distance to the sun? 150 million kilometers. Light, the fastest thing in the universe, takes a full 8 minutes to make that trip. So the sunlight you feel on your face right now, it actually left the sun before you even started your last coffee break. And this right here introduces a huge shift in how we see things.
Because when we look farther out into space, we are, by the laws of physics, looking deeper and deeper into the past. The two are completely fused. And listen, this isn't poetry. This is the literal operating system of the cosmos.
This means every star you see in the night sky is a ghost. You're seeing it as it was years or decades or even millennia ago. Our closest major galactic neighbor, Andromeda, the light we see from it tonight is 2.5 million years old. Our telescopes are literally time machines, and that is exactly how we know the universe's origin story.
Okay, wait a minute. This is all incredible, but how do we know any of it? I mean, it's a great story, but what is the actual hard evidence that there was a Big Bang nearly 14 billion years ago?
That is an excellent question, and the answer is our entire model isn't some wild guess. It's a scientific theory built on 3 colossal, cross-verified pillars of observational evidence. If you take even one of these away, the whole thing falls apart. But all 3 of them point to the exact same origin event.
So, pillar number 1, redshift. You know the sound an ambulance makes? How the siren's pitch drops as it speeds away from you? That's because the sound waves are literally being stretched out. Well, light acts the same way. Back in the 1920s, Edwin Hubble noticed that the light from distant galaxies was stretched, or redshifted. And the further away the galaxy, the more its light was redshifted. There's only one inescapable conclusion. The universe is expanding. Everything is moving away from everything else.
Pillar 2. The cosmic microwave background. Now, if the universe really did begin in a hot, dense state, there should be some leftover heat signature, right? An afterglow? Well, in 1964, 2 radio astronomers found it completely by accident. It's this faint, uniform microwave hiss coming from every single direction in space. It's the light from just 380,000 years after the Big Bang, the moment the universe finally cooled enough to become transparent. We are literally looking at the baby picture of the universe.
In Pillar 3, the elements themselves. Big Bang theory lets us calculate the exact chemical recipe of the early universe. It predicts that in the first 3 minutes, the cosmos should have cooked up about 75% hydrogen, 25% helium, and just trace amounts of lithium. And guess what? When we point our telescopes to the oldest, most pristine gas clouds and stars out there, we find that exact chemical signature. The math and the observation, they match perfectly.
Okay, so the Big Bang made hydrogen and helium. Got it. But what about, well, us? The carbon in our cells, the oxygen we're breathing right now, the iron in our blood. Where did all the building blocks of life actually come from?
For that, you need stars. You see, massive stars are basically giant nuclear forges. For millions of years, they live in this stable, almost monotonous cycle of fusing hydrogen into helium. But when that fuel starts to run low, gravity begins to win. The core crushes down, temperatures skyrocket, and a frantic, accelerating race against total collapse begins. The star fuses helium into carbon for 1 million years, then carbon into neon for 1,000. The timeline just gets shorter and shorter and more violent.
Each stage of this fusion releases energy, and that energy pushes outward, holding the star up against gravity's unbelievable crush. But then it creates iron. And iron Iron is the ultimate stellar ash. Fusing it doesn't release energy, it consumes it. The furnace at the heart of the star just goes out. In that instant, gravity wins. The core collapses, and the entire star detonates in a supernova, scattering all those newly forged heavy elements across the cosmos.
And this brings us to that famous, incredible insight from Carl Sagan. It is so important to understand this is not a metaphor. It's not a nice little poem. It is a literal chemical inheritance. The very atoms created in the violent death of a star billions of years ago were recycled into the gas cloud that eventually formed our sun, our planet, and you.
And this is how it all circles back to you. We are walking, talking collections of stardust. Or, as the author Ariel M puts it, a clump of fat in salty water, animated by chemistry forged in supernovas. This is your thermodynamic wealth. The elements you're made of are incredibly rare, they're valuable, and they were created at an immense cosmic cost. You exist in a 14 billion-year reference frame.
You know what's truly profound, though? It's that this star stuff, this clump of matter, has become self-aware. Humanity is the universe's way of understanding itself. Through our science, our curiosity, our ambition, the cosmos is finally piecing together its own story. We are its ambassadors to knowledge, and we're tasked with understanding this inheritance, building upon it, and fighting back against entropy.
So, how do you actually apply this 14 billion-year history today, right now? You use this framework. The book, the knowledge of this cosmic origin, is this source code. The tutoring, the process of learning and applying that knowledge, is the training. The CFO, your own strategic decision-making, is the runtime. And the portfolio, what you actually build in the world with that knowledge, is the output.
And this brings us to the final and most critical question. This isn't just some abstract intellectual exercise. This is your origin story. You are the current expression of a 14 billion-year cosmic legacy, forged in fire and armed with knowledge. So, knowing all that, now that you know exactly where your atoms came from, what are you going to do with them today?